Good afternoon, everyone. Welcome to today's webinar, the AMR Revolution, Here and Now, Transforming the Warehouse and Logistics Industry. This event is brought to you by Geekplus and SHD Logistics. My name is James Berman. I'm the editor of SHD Logistics, and I'll be your host for the session today. Thanks for joining us. We're always grateful that you've taken the time out of your busy schedules to be with us, and we hope it's going to be really valuable to you. I will run over today's event briefly, but I have just a few announcements first before we begin. This webinar is designed to be interactive, so you'll see a dock of widgets at the bottom of your screen, which will allow you to learn about today's speakers, participate in the Q&A session that will take place at the end of the presentations. Lastly, if you're experiencing any technical issues today, please click the help widget found at the bottom of your screen or type your issue into the Q&A area, and we'll be happy to give you some one-to-one assistance. Okay, so we have a fantastic lineup for you today. Speaking first will be Simon Houghton, Head of Sales and Marketing for the UK and Ireland for Geekplus. That'll be followed by Barry Pemberton, Solutions Director at AMR Material Handling, and Andrew Coffey, Senior Manager at ASDA. The purpose of today is not just to discuss AMR technology in theory, but also to take a look at how ASDA has implemented it within its operation with great success as a real-world example. So once we've heard from our speakers, we'll then move on to the question and answer portion of the event slightly later on. So without further ado, thanks once again for joining us, and I'm now going to hand over to Simon.
Good afternoon, everyone. Nice to meet you all, albeit virtually. Yeah, my name's Simon Houghton. I'm Head of Sales and Marketing for Geekplus here in the UK and Ireland. Yeah, just like to talk to you a little bit about Geekplus today, really sort of where we've come from, where we're going, and then obviously talk about some key solution overviews and more specifically talk about one case we're particularly proud of with ASDA and AMH, which we'll come on to later on. So first things first, a little bit about the company. I always align Geekplus with sort of the tech companies growing in sort of early 90s, and the rate of growth was so quick. So we've gone in the space of 6-7 years from a very small Chinese Hong Kong company up to well over 1,500 employees. We have over 400 patents now. We own and operate 3 to 4 of our own warehouses, smart warehouses, which run a number of robot technologies. And we have our own own and operate 2 of our own factories where we have robots making robots. We are now certainly in the logistics sector, have #1 market share for AMR solutions, and over 300 customers globally in over 20 countries now. We've been able to grow this quickly. We've had a lot of external funding. Certainly the last round of funding was over $200 million, and that's allowed us to grow internationally much quicker than normal. We do have AMRs for all types of scenarios, certainly in the warehouse and factory environments, and we've reached a target milestone quite recently of over 20,000 robots operating worldwide, 24/7 in some cases. Okay. So a little bit about AMRs in general. Our target as a company is we will look at a solution and always look for a fast payback on that solution. So typically in the UK market, we'd be looking between 1 and 3 years payback. We'd also be looking at 2 to 3 times efficiency improvement on pick rates or sortation rates, accuracy improvement up to 99.99%, and a very fast deployment. Sorry, got the printer going there, on the project. So this is warehouse automation with not your typical standard automation where you perhaps be looking at 18 months, 2-year deployment from contract sign-off. We'd be looking into a matter of months rather than years. Okay. One of the other parts for AMR systems in general is extremely flexible, very scalable, and very reliable going forward. Okay, little bit about who we've worked with. I mentioned before, we've got 300 customers globally, lots of well-known names there, obviously in the UK, including Asda, many well-known fashion and sports retailers, including Nike, Adidas, globally lots of 3PL customers, manufacturing, pharmaceutical, right across the gambit of different verticals. Okay, little bit in a minute, just wanted to show you this little slide really of just sort of a brief outlook of all the robots we have currently in the family, and that really stretches across to robots for all solutions really. I'd just like to show you a little bit of a clip on what's coming up. So we've obviously in our current lineup got robots for goods to person picking, sortation, forklifts moving stock around the warehouse, but there are a number of things coming through very soon. Okay. So I don't really can see the video here. It's just talking about our new, really something which is coming towards the end of the year. So this is your typical pallet store, bulk store for pallets, auto storage and retrieval system, but using robotic technology this time as well. So the aim is to be more flexible, more scalable, lower cost, and more accurate than perhaps more traditional systems. So this is something which is coming through, say, towards the end of this year, and it's designed to work together amongst existing AMR solutions to feed as a bulk store, feeding a buffer storage system, and work alongside also existing in-house systems as well. So something to watch this space on going forward. Okay, so just on the solutions themselves, we have goods to person picking, which I mentioned before. We have totes to person or bin to person picking systems now. Order to person, so this is where the robots will meet the pickers in the aisle. We have that technology now available. Smart sortation, which I'll come on to in a little while. Moving, so smart moving could be literally just moving pallets or totes or cartons from one point to another within the factory or the warehouse. And smart forklifts going forward. Overall, all of the AMR solutions, what we're looking for is in any site, typically where you've got manual operations, 50% of an operator's time is normally spent in transit. Okay, so that's where AMRs can help, because it's dead time. There's nothing being produced, so we're aiming to reduce that 50%. So the robots will do the moving for the operators, and hence avoid accidents, improve efficiency, and go over to the benefits I mentioned earlier on. Okay, so just a little video on our picking system coming up. So as you see here, this is a site where we've got both our shelf-to-person systems, or shelf or pallet-to-person systems, working alongside the bin-to-person systems. Now, the shelves themselves can be pretty large, up to sort of 1.35 meters square as a base, up to 2.8 meters in height, and up to 1 ton. So pretty flexible on those, and you can pick from the shelf, and the shelf is fully configurable. You can work with goods on hanger, or pallets directly, and you can have a mixture of pallets and shelves in the same site. Also, our more recent solution going forward is the tote to person or bin to person solution, which you'll see in the background coming up now. And I say the two can work together as a hybrid system. So if you've got a mixture of goods stored into totes and shelves and pallets, you can merge the two and all work together to become a full goods to person picking system. So this would the typical advantages of these systems over, say, your manual pick would be to double or triple the pick rate at least over the current manual operation, and improve accuracy, as I mentioned before. Okay. As far as the design of the solution, it's very flexible. So depending on the nature of business, whether you're picking piece orders for e-commerce or full case picking for stores, for example, or even picking to pallets or picking to roll cages, the system is very flexible from there. Okay, onto the sortation system. So as you can see, there's a number of robots which we can use for sortation. Now, sortation for us is not just typical parcel sortation, but it could mean any sortation which is needed, where you're picking up a load. That could be a carton, a bag, a tote, or a pallet from one point, and then routing it to a number of different destinations, which could be changing dynamically all the time. So that's our sortation system in a nutshell. I'd say there's a number of applications how this can be used. So that leads me over very nicely to a video.
As a global provider of robotic logistics systems, Geekplus has been working with Asda and the Walmart companies for quite some time to develop the United Kingdom's first national sortation system using autonomous mobile robots. The operation employs 60 conveyor-top sorting robots here at the South Emsall site. The induction system requires very little tack time from the operator, and the system sorts about 2,000 sorts per hour to 34 destination locations. This system only operates robots when they're actually carrying parcels, and that makes the system highly efficient so that Asda can be more green. More robots can be added, and the software can be optimized to manage the additional traffic so the existing floor can become more dense. The flexibility and scalability of the operation also means that the existing floor can be easily expanded and more sort destinations can be added. It's a very tight integration of software and hardware, not only from the Geekplus system, but Geekplus to AMH systems for the conveyance and induction systems, as well as the WMS at Asda to you. This is how the system provides so much efficiency and intelligence.
This site has been a great case study in being able to do the sortation piece in both a forward and reverse scenario. So that's from a customer returns to also delivery to store. We've been able to grow with the business and be able to increase capacity in a staged manner, and it's been really good to develop a solution like this as a first in this country.
The connections between the three partners, Geekplus, AMH and Asda, are crucial to the operation's efficiency. There is a huge volume of background traffic going on through collaboration tools, so the networking and communication between these teams is critical.
Proud to see the system working so well, delivering great performance, really hitting some of the metrics it was designed for, and it's part of our journey for AMRs along probably the next few years. Great starting point.
Really pleased with the success of the project. It's certainly achieving expectations, and this has helped improve efficiencies on site, saving labour, saving costs, and certainly going to plan from the start.
Geekplus and AMH are extremely proud about this system. It's a milestone for robotics in the UK, and it's also a milestone in Geekplus's relationship with Asda, to help them deliver the best experience for their customer, as well as with their shareholders.
Okay, thanks for watching that. Hopefully that was enjoyable. Really, I'd like to introduce our partner, one of our channel partners, AMH Handling, and Barry Pemberton, who's the Solutions Director. AMH have been a channel partner for Geekplus for the last 2 years, and it's working particularly well. And I'll hand over to Barry now, who will tell you a little bit more about how we work together, and obviously they're talking about the actual implementation of this solution, which we've just shown.
Thank you, Simon. Thank you, everybody, for joining today. I'm Barry Pemberton from AMR Material Handling. We are an integrator of sortation systems, conveyor solutions, all different manner of warehouse solutions across the industry. We were incorporated in 2015 and we're predominantly a maintenance, support and service provider with a small element of solution development. We've grown through the business over the years, and we pride ourselves on excellent partnerships with both our suppliers and our customers. We work really closely with ASDA and have done since the commencement of our business. And like I say, the partnerships are key for us in providing the solutions that end customers need. We really want to make sure that we provide the best possible solution for the task, and that led us to recognise the AMR revolution that was coming in, and we're able to partner up with Geekplus. Our relationship with Geekplus goes back to 2019, and a group of us went out to Beijing to do some training, which was really interesting and a very informative visit, and got to see some of China as well, which was interesting. And we are an approved provider of Geekplus solutions. Over the last couple of years, we've been working on quite a number of solutions, right through picking the multi-shuttle robots as well as the sortation. And our sortation piece was the first bit that we really worked on. So we were fortunate enough to have a partner in ASDA in trusting both ourselves and Geek to provide this new solution as a groundbreaking one within the UK. And we had some challenges in the sense that there was some operational things that we needed to adhere to. So the solution itself was developed together with both Geek, AMH and ASDA in making sure that we could utilise the current infrastructure in terms of the palleteiners that are used and also a secondary sort. So what we had to do was build it on a mezzanine platform in order to discharge at the correct heights and offer the flexibility to be able to do a secondary sort on the outfeed. The original specification for the sorter was to sort 2,000 parcels an hour to 36 destinations, and also to deliver that in both a forward and reverse model. And what I mean by that is returns and also delivery to stores. So in order to do that, we had to develop a bespoke chute. So we were able to stow the chute away as well as be able to do a secondary sort from there. So the palletainer itself is a 1650 high palletainer, and with our integration into the ASDA's WMS, we can discharge directly into the end destination without any further scanning, etc. Additionally to that, we wanted to make sure that we created an ergonomic infeed for the operators, and that they didn't need to be scaling stairs, walking over all different manner of apparatus to get there. So we were able to bring full cages with return stock or forward volume directly to the infeeds and place them on a comfortable height for the operator. The induct has been designed so that we can't put on parcels that don't fit the solution, and the infeed conveyors are quite key in making sure that over length parcels, over height parcels are not placed onto those conveyors, otherwise obviously it won't transfer correctly onto the robots. As previously stated, we developed a key piece of middleware that went in between both the AMH equipment, the ASDA WMS, and also the Geek robot solution, creating key bespoke HMI, as well as reporting screens and the integration that would be required for that solution. As stated at the beginning, we're a full end-to-end turnkey solution provider, and we don't leave when we've completed the project. We provide maintenance and support services to support the asset throughout its life cycle. We have a full maintenance team that are then resident on site on this type particularly, and they're qualified up to and we follow the world-class engineering maintenance platform, providing the importance and what needs to be provided on site. As I say, we can provide full 24/7 remote and also residential and visited service. That was, in a nutshell, the solution that we provided to ASDA. And that leads me on to, I've got no videos for you, unfortunately. That was Simon's bit. And I'd like to introduce you to Andrew Coffey, who's our partner in this. And thank you for listening.
Okay, afternoon guys, I'm Andrew Coffey. I look after engineering development within ASDA Logistics. I guess we'll start with a bit of a shameless plug, and also for context around those of you who might not have known what the Tou Service is. Tou is our parcel delivery company, operating for about 5 years, moving both our own George.com parcels but also third-party parcels into our stores for click and collect by customers. Then also moving return parcels, they return to our stores, back through our network and back to ourselves, or again to a third-party client. It gives customers a really kind of convenient parcel shop where they can go park up easily and do shopping at the same sort of time. And also we have some pretty cool in-store tech as well. Currently there's around 140 brands using the service at the minute, and we are the fastest growing pick-up and drop-off service within the UK. We think we'll do about 20 million parcels this year, so some decent scale and growing rapidly. We're also quite keen to innovate. Within the store space, there's an awful lot of in-store automation, both for parcel collection and parcel drop-off from a returns point of view. So lots going on within that Tou business, which brought about the need for us to then go and invest in more capacity. So I guess focusing particularly on the solution we're looking at, we built the service initially around a conventional cross-belt sorter within our sort centre, but we're growing rapidly. We need to support the need to sort more parcels, handle more clients, and sort to more destinations as well. And also, because we've got a next day service, we need some resilience. So having a secondary sorter alongside the original sorter gives us that level of resilience. Also, I think we, as a business, are evolving rapidly. Obviously, it's been bought. We've got new owners now. Lots of new, exciting strategy things to look at. So any solution we put in place needed to be flexible, scalable, and able to adapt and change as our business changes. So we think this AMR solution gives us exactly that. In terms of the install itself, we installed it within a building that is our sort centre. So we have the old sorter in there, but it's also a fast-moving ambient grocery centre. So we were servicing about 100 stores worth of fast-moving ambient grocery at the same time as installing this sorter. And we did a great job, and AMH did a great job of getting it in and causing little disruption. So I'd say it's alongside the current sorter, we managed to get it in there with pretty much no disruption at approaching Q4, but approaching peak time. So that was quite pleasing. We sorted the first parcels pretty much bang on schedule, and we were using it for Christmas peak. And we got within the first week to about 75% of design capacity throughput. So through our testing and then through live volume itself, we got to about 1,500 per hour on a fairly consistent basis. So we were really pleased with that in terms of how quickly we can turn the thing on and get it up and running. I guess just the final thing for me is around how we see AMR technology going forward. And I mean, I talked earlier on around how the business is changing. We have new buyers, exciting strategy, that sort of thing. So anything that gives us flexibility is something we're looking towards. We've also got quite a fast developing innovation culture within ASDA Logistics, both within the business, and we get great support from the exec level down around a lot of our innovation ideas. Of let's put a lot of interesting trials and interesting things into the network in the last few years, and there's a real commitment to being certainly a fast follower rather than being kind of bleeding edge, but certainly on the cusp of innovation whenever we possibly can. And across our network, obviously we're quite mature in our food network, but we've got a rapidly growing non-food network and a rapidly growing sortation area. And we do believe that we can use AMRs across multiple sites across that network. And again, the point we can put them down quite quickly. We can move them, we can make them bigger, add more robots, change the area we're working on, and nothing's being bolted to the ground. I mean, we've done well with some conventional automation over the years, but that is very heavily bolted to the ground. So something this flexible and scalable really appeals to us going forward. And I guess the proof being in the pudding is we've already got AMR project number 2 underway. We won't see anything live until into next year now, but we're a long way into the design phase and kind of development phase of that second project, which I think just shows the direction we're looking at going in the future years. That's pretty much it from me. Thank you very much.
Thank you very much. Thanks to all of you, actually, Simon, Barry, and Andrew. That was excellent and really, really insightful. So we're now going to move on to the question and answer portion of our event. As a reminder, to participate in the Q&A, just type the question into the text box or click the Q&A icon at the bottom of your screen. If we're not able to answer all submitted questions during today's webinar, we'll be sure to share them with Geekplus, who can reply to you offline. So I'm going to open with some of my own questions first, and then there'll be an opportunity to take your questions. But so first of all, I'm going to open with a question to Simon. Simon, we talked about the benefits of AMR tech over other alternatives, but you mentioned mainly pick rate there, increased pick rate. I wonder if you could give us a bit of an overview on what the other benefits of AMR tech might be. Yeah,
sure. I think probably the two buzzwords which I hear most often is flexibility and scalability of the system. So if we take, for example, a goods-to-person picking system, essentially what that contains is QR codes on the floor, mobile shelves, and the robots themselves. So if you think of it, when we design these systems with QR codes on the floor, it's a grid system. So if, for example, the storage requirement changes and the warehouse expands, you just literally sticking on more QR codes, adding in more mobile racks, shelving racks. If the throughput of the system changes, so you've got more presentations per hour of the racks into the operators, then you can add on more robots, and adding in a new robot to an existing system will probably take about 20 to 30 minutes maximum to upload it to the network. There's no training needed. It's literally just joins the team and will continue to work. And then obviously the more robots, the more processing or more throughput you can do from the system. So certainly flexibility and scalability. Time of implementation is also quite key. So, certainly I showed the slide earlier on, but UK projects were looking at anything between 12 and 20 weeks from contract sign off to go live, depending on the size of the project. So very, very quick. And what that does allow you to do is then look at perhaps an overall very large solution, look at a plan for 5-10 years where the business is going, but you can then implement it in multiple phases. So you don't have to push that large investment from day one. You can do a yearly update if necessary because of the quick implementation.
Perfect, great. And I think now I'll move to a question for Barry. I'm going to try to give everyone a spread of questions. Barry, we've talked about the turnaround time, and I know that's, I believe, about 2 to 3 months. During that time, I'm wondering what preparation is required within the warehouse prior to the installation happening.
So within the solution that we provided on site here at South Elmsall, the main real preparation was making sure that we got all the power requirements in there, as well as clearing the floor space ready for the solution. Now, if you was going directly onto a concrete floor, there's very little preparation, but we were providing a 1 metre platform across the whole solution, and so therefore, whilst we were waiting for the robots to be delivered, we were building the mezzanine, we were putting in the in-feed conveyors and getting in the majority of the infrastructure in place, ready for when the robots arrived. Obviously, they were coming in. Yeah, it's more about preparation of the area rather than and bringing the infrastructure in place.
Perfect. And then just briefly, the actual installation window, I don't know if you want to take this question, but the actual installation window, what sort of time frame is that, and what does it look like?
So we worked back from a go live. So the idea was that we would hit November, and so we scaled it back from there. So it was roughly about 3 months in the sense that went from when we hit site to when we went live, it was approximately 3 months, but that included all the mezzanine build, it included the conveyor build, it included all the wiring for the chutes and whatnot. So yeah, it was about 3 months.
Perfect. Great. Thanks for that, Barry. Andrew, on the topic of implementation and installation, you mentioned the technology was implemented during the peak Christmas period. I was just wondering how that went, particularly during such a busy time.
Yeah, I mean, back to sort of Barry's earlier question on timings as well. We were 9 months from our approval internally to go in line, which is pretty rapid from an ASDA project point of view. So it is a quick install. In terms of installing through Q4, I think planning is always the key thing for us. I mean, we're fortunate we could barrier off an area, so an area was fenced off and it was a no-go area for operations, and likewise the install team couldn't go outside of that either. We're also doing it through COVID, because we're doing it through kind of Q3, Q4 last year. So we're really careful around how we got people on site, how we manage people on site, that sort of thing. But I think just planning it well, staying true to the area we're working in, and then great communication between the install guys and our ops guys kind of got us through.
Perfect, great. I'm gonna come back to some of my own questions a little bit later, but we've got audience questions absolutely flooding in. So I'm gonna take some of these first. So the first question that's come in, and please feel free to shout out as to who wants to take this. But a person's asking, what is the difference between an AMR smart forklift and an AGV?
I can take that one. I think obviously the AGV sector is continuing to be around, but certainly I would say the big difference on an AMR forklift is the ability to integrate as part of a larger robotic system. So, for example, the forklift could pick a pallet and then hand over to one of the smaller AMRs to route it longer distance round to the other side of the warehouse and so on. So I think a lot of the AGVs a lot of them are typically just focused on a particular task, and it's relatively simple. Normally, the traditional AGVs were normally more costly. The cost of the units are higher. The speed is typically slower, and the implementation time is typically longer as well. But certainly, the same points as before: flexible, scalable, lower costs would apply. But also, you can build it in as part of a larger robotic system to handing over to different types of robots. So we've got AMR forklifts effectively bringing a pallet that could then link up to a robot palletizing arm that could then pick full cases, hand over to a carton moving robot or a pallet moving robot, and go from point to point all the way through the business. That's probably where Geek has a big advantage, is we can employ a very large system. Hope that helps anyway.
Perfect. Yeah, no, I think that's a good answer. The next thing that was on the list, it's actually come up a couple of times. I know that ASDA runs quite a large-scale operation, I suppose, but there's a few people asking about smaller operations. So somebody would say, would this work quite so well in a medium-sized warehouse? And then I suppose a follow-up question to that is, not necessarily about warehouses, but for a small business. So I guess the question there is, what's the scalability on size here? Is there too small an operation to make this worthwhile? I don't know who wants to take that.
I'll take that.
Go on, Barry.
In terms of
you can both have a go if you like.
Go on. No.
I was just going to say that we've got from a Geekplus perspective, we've got project anything from a single workstation, single pick station up to 50, 60 pick stations. So we are and have sold projects in the UK and Ireland, which you'll be hearing more about later on, which are anything from a small to medium-sized enterprise all the way up to a sort of global businesses. And that's another benefit of the system. You know, the cost of the system is a lot more accessible to smaller businesses. And I would say from a warehouse perspective, if we're talking goods to person picking, if you've got 8 to 10 operators doing picking and put away, then potentially that could be a qualification of a goods to person picking system, because that quantity could reduce to 1, 2, or 3 pretty much overnight using a goods to person picking system. But obviously, if you've got two people in a very small space where they're right next to shelves, then there's not a huge amount of benefits there because the cost of the return on investment might not be as strong as perhaps a slightly larger system. But certainly 1 or 2 stations, 8 robot type of system could be employed and has been employed in many small to medium enterprises in the UK and globally. Sorry, Barry, over to you. Right.
I was just going to reiterate what you're saying there. The solution is governed around how many workstations, and then that also dictates how many robots. The workstations is obviously dictated by the throughput requirement, so the solutions can be scaled from something really small. For instance, I've done a solution that's just 2 workstations, really low throughput, which is roughly 3 meters by about 8 meters long. So you can fit it in a really, really dense area, really, really small area. But yeah, it's all based on throughput. So the more throughput you need, the more space you need.
Perfect. Okay. We'll move on now. So this person's asked 2 questions, but they're good questions, so we'll go with them both. Barry, how are oversized parcels handled by the system?
So there is a fixed size on the solution. So if it's an oversized, then it will have to be donated manually via the scan guns. So we do have an absolute maximum size parcel. Now, what the solution does that we implemented on that site was 150 mil by 150 mil, 10 mil thick, up to 600 by 400 by 400. So quite a big range, and given that it's 2 house deliveries, it covers the 90-95% of the throughput. But yeah, if they exceed that, then they need to be managed in a different way.
Okay, great. And the second question from this audience member is to Andrew. And they're asking, what were the key design considerations made when you were choosing the right technology for this operation?
Yeah, just to finish off the first question, the bulk of our parcels are kind of fast fashion type items. So that kind of size range that Barry talked about is pretty much sweet spot for us. We do get a bit of oversize through, and we have a manual area for oversized stuff, but we're talking about very small percentages of our volume. So the bulk of it will go through this system. In terms of our considerations for designing it, I touched upon it in the slides. Flexibility is one thing for us. So we've got a business that's changing all around us. The sortation package is growing like crazy. So we needed to act fast, but also act in a way that we could then build on again and again and again, or we can change a little bit. So flexibility, ability to adapt it quickly as well as in all directions, where there's more throughput, more destinations, that kind of thing. And also, it's a cool solution. It's great PR for a growing business as well, and we shouldn't shy away from that. It is, although that wasn't our kind of primary rationale behind it. But yeah, definitely kind of scalability and be able to react quickly with it.
Perfect. Okay, great. Thank you for that. Just looking through, there are absolutely loads of questions, which is fantastic. Thank you, and keep them coming, please. As I said, if we don't have time to answer them all in this session, we'll pass the questions on to the relevant people. So please get them in while you can. The next question is a really interesting one, and not something I'd actually considered. But the question is, are there any security issues to be aware of with this technology?
I can talk from our end. I'll talk from our end in terms of what we experienced. I mean, obviously, we at the time of install were still part of Walmart, and their kind of security protocols are pretty mega. So one of the most complicated thing for the project for us was getting the kind of Walmart security clearance around all the different messages that fly around into our network, into Walmart's network and back. So yes, but that was all about messaging and scanning parcel data and individual security and all that kind of stuff. We didn't deem the robots in any way to be a security risk. It was more about the information that was on them as they were passed from place to place. So that was a challenge for us, but it's a challenge for us in any project. So this is no different to any other project in that kind of way. In terms of specific things from the technology, Simon, you might have a view, but nothing we saw over and above anything else.
No, I think only to add to that, I think that really for on a AMR solution, whether it's sortation or picking, Geekplus, from our side, really, we only need the key information. So it's order data, as in what we need to pick, when we need to pick it, inventory updates back through to the customer's WMS. So there's only a limited amount of information which we actually control or need. But we've as a company, as a business, we've integrated with most of the major WMS companies and also in-house bespoke systems as well, and never had particular issues with security. We only need a set control around that. So hopefully that answers the question.
Yeah, great. Anyone anything to add, or if not, I can move on. Okay, so there are a few more questions about the technical side of things, but we can come back to those. Let's take a look at. Okay, this is a good question. Is there any special floor requirements for AMRs, mainly picking and sortation AMRs? Simon, I think.
Yeah, happy to answer that one. So obviously on a standard concrete warehouse floor, obviously the sort of things we're looking at are damage or very large expansion gaps or bolts from old racking. All of these sort of things would have to be addressed. Flatness is important, but it doesn't have to be perfect. So the robots have a little bit of flexibility and suspension. If you're talking a goods person picking system, you could potentially be carrying a rack up to 2.8 meters in height. So flatness is important, but we're working on a site at the moment which is the concrete floor is probably 35, 40 years old, and generally there's a few minor repairs, but it's not a major issue. I think the only other thing on talking about, say, working on mezzanine floors, so we can work on mezzanine floors, is to think about the dynamic loading of weights moving around that floor, and the floor obviously then has to be prepared from a weight perspective as well to consideration. So there are, yes, considerations, but not always impossible to get around. But again, case specific, I would say on that one.
Mm-hmm. Okay,
just to add my kind of experience with that one. I mean, dynamic loading is something we are looking at in our floors. That is important to us. But for this particular application in South Emsall, it's located opposite a coffee grinding factory, and it's quite a dusty site. We get a lot of dust into the building. So I think what we did learn quite quickly is floor cleanliness is quite important. We're not talking about it being a ridiculous requirement of cleanliness, but we've certainly got planned in routine cleaning of our platform to make sure that it stays dust-free, because we had a bit of an issue with that at first, but it's down to that site being a particular dusty site rather than anything technology related.
That's a good point.
Perfect. Okay. Okay, someone there's a couple of questions here about mezzanine, but Barry, you did cover it. Are there any specific floor requirements for mezzanine floors in particular? There's a few people asking that.
There's a few, like Simon was saying, it is kind of take each project on its own merit, really, depending on the weight and everything. But we've used a resin top on the boards. It's normal particle density board on the mezzanine, but then it is coated with a resin top for wear. There are other options, but yeah, it does have to be treated. It can't just go on particle board.
Okay, I hope that answers that, because there were a few people there asking that question. Right. Okay, so this question is to do with servicing, and it is something, servicing and maintenance is something we've touched on. But the question is, how do you manage the servicing of the fleet of AMRs in order to limit the operation disruption?
So what we built into the solution a maintenance point. So we've got a maintenance part of the platform which is outside of the AMR solution, which is all controlled with interlock gates. So we can call individual robots out using our CMMS system, so we can track what's been done and when. And okay, we can call those individual robots to those areas and then take them out without stopping the system at all. The system is designed to have a number of robots sat within the maintenance area. So when you're doing the maintenance on one, you replace it with one of the ones that you've got sat So you swap them over like that. So in terms of operational impact, it's marginal. It's virtually non-existent. The maintenance is then done. Generally, it is more around cleaning of sensors, etc., making sure belts are okay and that sort of thing. Make sure e-stop buttons are operational. But in reality, it's very, very little impact.
I think just to add to that as well, AMRs in general, there's not a huge amount of parts which need maintenance. I mean, certainly on a lot of them, you may be only talking 20, 25 parts which need sort of checking or maintenance. You drive wheels, batteries, for example, battery change probably every 3.5 to 4 years, depending on the use. Drive wheels maybe once a year, depending on the use. But there's not a huge amount of maintenance. And also, as Barry mentioned before, that you can be performing routine maintenance on one or two of the robots at any one time, but the rest is continuing to work. So it's not the whole system needs to go down. Say that's the flexibility of the system. And if one goes down on a particular area, again, the rest can carry on the work from there. So quite flexible.
Yeah, perfect. And Barry, that's a good point that you've mentioned batteries there, because there is a question here about that. I don't think we've really covered batteries too much in the presentations. So I wonder if actually it might be best, Andrew, if you able to answer this question based on your experience with the technology. What is the battery life like? How often are you charging, etc.?
Yeah, the robots opportunity to charge whenever they can. So there is no kind of formal charging regime as such. It's all within the software of the system. So that if a robot is idle and has gone beyond its kind of battery parameters, it will go off and charge itself and come back again. So it's fun to watch them as they kind of wander off and charge themselves and come back again. But we haven't really concerned ourselves too much with it. It all works very well. So I think, as long as you've got enough charging points for the fleet you've got, and we feel like we have, it kind of just happens without oversimplifying it, and it works quite well.
Can I just add to that as well? The batteries in general, the charging is fully automatic. It's designed to work 24/7. As Andrew said, we opportune charge throughout the day. So for the smaller sorting robots at ASDA, typically that would be every hour and a half, and they would normally charge themselves to say 80% battery levels. The batteries we use are very high grade lithium-ion, highest tech lithium-ion batteries. I think they may even come out the same factory as Tesla's. So the larger picking robots, they would typically be every couple of hours. They'd be opportune charging. Each charge would normally take no more than 10 minutes. And when we design a system, we build in that charging time into the buffer of quantity of robots needed. So there's no downtime when any robot's charging, the rest are picking up the work. One other thing to mention as well, and I think from a safety perspective, especially with recent events in the news, certainly from a Geek perspective, that we do have a patented battery management system on all the robots. We monitor the temperature, the voltage, the state of the batteries of all the robots at any one time. So it's quite important to mention that as well. Okay, great.
So then I guess following the theme of batteries and power, there's a question here, a great question actually, asking what the sustainability gains can be made by using AMRs. How much power does each AMR require? Possibly Simon.
Happy to pick that one up again. Sorry. A typical charger for an AMR is a single phase charger. It's a 3-pin plug. So it's not, doesn't require huge power requirements on the robots. The robots themselves also will go into, if there's no work, they'll go into standby. So they're not using power when they don't need to be. It's not like perhaps a conveyor system which is continually running throughout the day. That they'll move when they need to move, and that's possibly one of the another benefits from AMRs. Andrew, I don't know whether you want to comment if you've had any particular experience from an ASDA perspective on power consumption.
Yeah, I've not got any hard stats. I think the point you make about the conveyor system is quite true. So obviously we've got both systems are side by side, and the crossbelt sort of thunders away most of the day. And if colleagues are going getting some more parcels put on it, it's still thundering away. Whereas you stand next to the AMRs and they just stop. And they'll use as many robots as they're required to use to sort what you're giving them. So it's very visible how much less activity they're doing compared to the crossbelt if volumes are low, which by definition I'd imagine means that they're using less power as well.
I think noise as well makes a difference, doesn't it, Andrew? It's quite a silent system, isn't it, the AMRs?
Yeah, I mean, it isn't the quietest sight, and if you look at the videos we did through our Go Live period, lots of kind of Christmas songs playing at full volume, so you probably wouldn't notice it in that particular building, but yeah, they are much quieter.
Okay, great. So I think actually talking about batteries has sparked a few people, no pun intended, sparked a few people to ask questions about any potential problems that can go wrong with the systems, and I think it is worth covering. What are the risks of any? So someone's mentioned fire, which is obviously a big one. But with this kind of technology, I suppose a secondary question to that is due to the power. Are there any restrictions on the types of products that an AMR can handle? Somebody's thinking hazardous chemicals or temperature controlled things as well. Perhaps do you maybe all want to take a go at that?
Yeah, I mean, well, hazardous, I guess it's case by case, but I mean, from the robots themselves, the battery is obviously sealed unit. In certain extreme environments, we do have a range of the picking robots which work down to -25, so in frozen environments. So all of those systems obviously need to be designed to cope with things like working within those sort of environments. So it's I think does that answer the question, I guess, to a point?
Yeah, I think so. Is there anything anyone else wanted to add?
So I suppose from a hazardous... Sorry.
Yeah, just saying from our point of view, obviously we don't handle anything hazardous through this part of the network, so we've not got any kind of experience of what we can and can't do. Everything tends to be just either general merchandise or clothing, so there's not a lot hazardous that goes through. So no real experience of that particular thing at our end.
Barry, sorry, I think we interrupted you.
Oh, just saying, in terms of hazardous and hazardous materials, the transition between conveyor onto robot's really gentle, so that would be fine in that sense. But as we've designed this system, you wouldn't probably want to drop it off how we are at this moment in time, but you would design a specific outfeed to be gentle on the outfeed as well. Obviously, we're doing fast fashion, so it can drop, whereas you wouldn't design it to drop a hazardous or chemical product.
Okay. So this is a good question, and it might allow you to talk about the guidance systems a little bit more. But someone's asking, what happens if a parcel is dropped and is on the floor? What happens within the technology? Does that cause any issues, or?
I'll take it. So when we were first commissioning, obviously when you were first doing it, there was a couple that went onto the floor. So I know exactly what happens with them. On the front of every robot, there's an anti-collision and obstacle detection. So if an item ended up on the floor, the robot would see that and then wouldn't move, and that would then require human intervention to go and replace that.
Okay.
Where we are at the moment is that very, very little ends up on the floor, only really, really like round products, because obviously if it's like a ball, it's very difficult to handle. So yeah, it can happen. It does happen. It's infrequent, and it would require a manual intervention to go in there to remove that particular item. But it wouldn't mean that the product would be damaged or anything like that, because the robots would stop and wouldn't drive over them.
Okay.
And just to second that from our point of view, first week or two we were seeing quite a bit going on the floor, and I think one of the key parts of commissioning was getting that interface between conveyors and robot right, so the sort of transition happened and things didn't fall off. Since that commissioning phase, a very, very small percentage falls on the floor. Generally there will be round or non-compliance or very, very thin items that shouldn't really be on there in the first place. There are so few now that it causes very little issues. We can leave them in there for a period of time, and the robots find their way around them. And then ultimately, when you've got 2 or 3, you might go in and go sort the system and go get them. But it's doesn't impact us from a productivity point of view. We're not seeing a massive issue from it, and it's a very, very low proportion.
Just to back that up one point as well, on the advice of when that happens, the robots themselves have like little headlights, little lights around them. The light will change colour, so it'll indicate that there's an issue, and the particular colour will probably say obstacle detection. The robots can also emit an audible warning, just on an alarm, and on the central operating screen as well, you can track robots and you can actually view that there's an issue from there as well. So there's various ways that can be alerted to the operator, to the whoever's on site who's qualified to effectively go into the site and remove obstacles.
Okay, perfect. I've got time for a couple more questions, and I've been saving this one towards the end because I think it's a really, really interesting topic. So the question is, do you think this technology spells the end of traditional conveyor-based automation solutions, or is there the capacity for both to exist within the market? And maybe probably Simon and Barry.
Yeah, well, I think from my perspective, no, definitely not. It's not the end, and I think there's a lot of cases where conveyors make sense, and I think the smarter view is to look at how you can benefit from both, and perhaps a long conveyor run for speed and reliability, and if it's not creating issues on the site, and then robots could be picking off the end of the conveyor and then perhaps transporting to an area where it's more difficult to run conveyors. So it's certainly not the end, definitely not. I think it's just look at it at intelligent ways of combining them both, really. So existing, and obviously a lot of existing sites have conveyors, and that's already in place. So it's not necessarily to rip those out. It's just then how you can deploy robots to then complement the solution further. So you've got a new route to go to. So rather than extending it, perhaps you could use robots to do that new route, or if it's more complex, or perhaps the routing needs to be more dynamic. So it could go from the end of the conveyor to multiple destinations. That's when AMRs can really help.
Okay. And anything to add, Barry, or do you echo those?
So I just want to reiterate what Simon said. I think that they need to work in conjunction with each other. The AMRs obviously offer really high throughputs in terms of pick rate, etc., for picking, but getting your product to and from those solutions needs to be considered. And so therefore, moving product over long distances conveyor would definitely be an option. And with every solution we've designed so far has had a conveyor element to it. And so I definitely see these as being as a collaboration. What I do see AMRs replacing is traditional storage solutions in terms of like cranes and multi-shuttles, etc., shuttle-based systems. I can see that happening. I'm not saying that it will, because they also have benefits, but I can see that where they fit, as well as sortation. But in terms of conveyor, I think that needs to be as a collaboration with the AMRs.
Okay, perfect. I've got time for one more question, and I think it's going to be a quick one, but we've had a fair few people ask it. So do you consider flexible financing options with these solutions, or is it solely a capital purchase? I think that's probably for Simon.
Yeah, yes, in a word. So yeah, you can spread the cost of the solution over a few years. We work with external finance companies who specialise in warehouse equipment automation for the automation sector, and yeah, I mean there's standard lease plans which you can even defer payment and no payments during the project implementation phase. Then the first lease payment will be due sort of after a month after go live, for example, and then that would be then spread over a period of years from there. But essentially what you're aiming to do is eliminate that capital expenditure and convert it to an operating expense. So yes, in a word.
Yeah, perfect. Thank you. Fantastic. And that is definitely all we've got time for the Q&A and for today's session. So thank you very much to the three of you. You've been great, and we appreciate your time and definitely your expertise on the things we've talked about today. Thank you as well to everyone in the audience. We always appreciate your attention and definitely your participation. We had loads of questions today, which was great. So within the next 24 hours, you'll receive a personalized follow-up email with details and a link to today's presentation on demand. So please feel free to share that with your colleagues and peers who may not have been able to listen to today's event. So once again, thank you very much to everyone and have a great day.
Thanks, James. Thanks, everyone.
Thank you, everyone.
Thank you.
Bye.